Hello ladies and gentlemen, and welcome back. In today's video we are going to talk actually about a circuit that is very common in electronics, and you must learn about it whether you are a beginner or advanced electronic hobbyist or maybe engineer, whatever. As long as you are into electronics, this circuit you have to learn about. Alright, so first of all, this circuit is called as um, voltage. All right, this pen is not working with me right now. That's fine. It will work. Voltage. All right, come on, man. Voltage. All right, let's use another pen. Why not? My luck. So voltage divider. Right, now voltage dividers, they come in various shapes. One of them is called resistive, right, which is the one we are going to talk about here today. The other types I will be talking about them in later videos. The resistive voltage divider consists of resistors connected in a series to each other, like the ones we have here, R1, R2. Of course, you can have maybe R3, R4, R6. However, or how many you need doesn't matter. So we have resistive um, voltage dividers. We have also what we call capacitive voltage dividers, and we have inductive and capacitive dividers, and we have so inductive dividers. We have maybe two inductors, or maybe a resistor and an inductor. Maybe with capacitive dividers, we have two capacitors, or maybe a capacitor and a resistor, because as you might know, inductors and capacitors, they have their own resistance. So in some sense, they are two resistive voltage dividers. So under the hood. Anyway, so if we take a look at this circuit here, we can see that we have a 3.07 volts battery. We have two resistors connected in a series, R1 and R2. Now these are supposed to be 1K resistors, but I always measure resistor values with a multimeter, because there's always some inaccuracies. As you can see here, so R1 is 978 and R2 is 984. So we have here plus, we have minus, so current through or flow through this circuit in this direction. So here at this point we have 3.07 volts, right? Now here we will have a voltage drop across R1, and finally here we will have at this node, since this is connected directly to ground, so this one is 0 volts. So now this will be the output of the circuit, which we can connect to um, any device we want, and this will be connected to ground, right? So we need to calculate the output voltage right here, right? How much voltage we have here. Actually, it's very simple. We can use Ohm's law, and then we will talk about some equation related to voltage divider. So before everything else, we have voltage, we have resistance. So Ohm's law, if you remember, states that basically that voltage, sorry, voltage, right, equals current times resistance, right? So um, let's first of all calculate the current for the complete circuit, because we know that resistors in a series, right, they the current will passing through the resistors will be the same. So we have first of all our total, right, to equal to 978. So I will calculate that. I will just grab my calculator. All right, so here we go. Now, all right, turn on. We have R1 978 plus 984, which equals to 1962. This is our total, right? So now we have voltage, which is 3 point, right, 07 equals to current times resistance, which is 1962. All right, so as a result of that, current equals to 3.07 divided by 1962. So let's clear everything here. 3.07 divided by 1962. I don't want to answer here, which equals to, all right, 1.564, right, milliamps. Now, since this is the total voltage, the current flowing through the circuit, now we can calculate the voltage drop across R1. So we can say that voltage across R1, right? So voltage across R1 equals to the current, which is 1.564 times 10 to negative 3, which is milliamps, converting that to amps, times resistance. Resistance is 978. So voltage across R1 equals to, so it's this number times 978, which equals to 1.53 volts, right? So since we have this voltage drop across R1, so voltage at this node here, let's call this the A node, right? So voltage at A will be 3.07 minus 1.53, which equals to, let's do the calculation here, 3.07 minus 1. Delete 1.53, which equals to 1.54 volts. So voltage at this point here is, right, 1.54 volts. Is there an easier way to calculate that? Yes, there is. And it's an equation, a very simple, straightforward equation, right, that we can use to calculate voltage in a voltage divider circuit, right? And this equation states that V out, so V out, which is basically voltage at point A, equals to, all right, R2 divided by R1 plus R2, right, times Vn. So if we use this calculation, V out equals to R2 is 984 divided by R1 plus R2, which is 1962 times voltage N, which is 3.07. So V out equals to, let's do the calculation. All right. So 984 divided by 1962 multiplied by 3.07, which equals to 1.53. All right, 1.4. So let's run these numbers. Now, if you remember, we calculated that value right here to be 1.54. So you can see this equation makes our life much easier. Now, this is for the theory part. Now, let's talk a little bit, or let me give you why these are important, voltage dividers, because they are used and implemented in many circuits. For example, in Schmitt trigger. So Schmitt trigger make use of voltage divider, especially when we are talking about transistor-based Schmitt trigger. Also in the 555 timer. So 555 timer use voltage divider. So what are the use cases for voltage divider? Well, we use them to create reference voltage, to reduce the magnitude of a voltage so it can be measured and used in signal attenuators and at low frequencies. All right, and many more, of course. So these are very, very awesome circuits to learn about. Now, a quick note here before going to practical. So I have breadboard here with a voltage divider ready to be tested. Actually, the values of these resistors are this one here, and this is the battery. So this value comes from this. So we'll do some practice. Anyway, if we have more, let's say, all right, let's say we have here more resistors, right? And we want to use this equation, right, to apply to this. We will deal with the first resistor as R1, and then we will sum all these other resistors here, so R1, R2, 3, 4, 5, and so on. We will calculate their total and we will consider them to be R2, and as such we can calculate V out at this point easily. All right, simple dimple. So now let's go ahead and do some practice, or do a practical example here. So in my breadboard, I will power this breadboard, and now I want to take the multimeter and measure the voltage. This is R1, okay, this is R2. So first of all, I want to measure voltage, and since we know that the voltage will be below 2 volts, so I would choose 2 here. Now this is V1, so I will see how much voltage we have here, and look what we have, 1.535, which is very, very close. All right, so 1 for VA we have 1.54, here we have 1.53. all right, now across R2 we have 1.547, and we have 1.54, right? That is very, very awesome, dear students. All right, so we have seen this practical example. Now if we want, since this is 1.5, maybe we can try to light an LED, right? Because if we take a look at these LEDs, if we take a look at the specification here, we can see that yellow requires very low voltage from 2 to 2.2 volts. So let's try to light an LED. All right, so the way I'm going to do this is something like this. All right, so I will put this LED here. I will connect the wire from the output, so this is point A, right, and from the other leg of the LED to ground. Hopefully this will turn on, and I'm trying to see if it's turning on. It doesn't seem like it. Actually, no, it doesn't turn on because the voltage is very, very low. To turn it on, what we can do, actually we can connect this directly to, as you can see here, and it turns on. All right, but right here, no, because the voltage is not enough. What we can do, we can change the value of R2 or R1. We can use this equation. Actually, this is very cool, dear students. Since we want V out to be 2 volts, right? We can use this equation, so we can say, okay, we want the output to be 2, which equals to R2 divided by R1 plus R2. So let's determine that we want R1 to be, let's use R2. We want R2 to be the same as here, 984 divided by R1, because now we want to select a value for R1 that ensures we have 2 volts, right? Plus 984 times voltage in, which is 3.07. Now we can solve for this to find the value of R1 that will ensure we have 2 volts output. We can try that actually. So the way we can do that is This will equal to 2 over 984 times 307 equals to 1 over R1 plus 984. All right, so actually let's keep it here, 900. You get the idea. So we multiply these two numbers together, which are 984 times 3.07. All right, this is over 1, so we do cross multiplication. So we have 2R1 plus 984 equals to 984 times 3.07, and then we have 2R1 plus, we multiply 2 by this number, so it will be 2 times 984 equals to 984 times 3.07. Then we divide by 2 and divide here by 2, so we get rid of 2 in this equation, and we get rid of 2 in this part here. So we'll have R1 plus 984 equals to 984 times 307 divided by 2. All right, so now R1, all right, continue here, R1 will equal to 984 times 307 divided by 2 plus minus, it will be minus 984. We do the calculations, right? We find the value for R1, and it will be, let me do the calculation. I don't want to be lazy, guy. So 984 times 3.07 equals to this value. Divide that by 2, we get this value, minus 984, we get this value, which is a resistor value. So R1 should be 526. All right, so since there's no resistor value which is 526, you will select the closest value to this number and you will get the desired output. How awesome is that, dear students? I know the video has got very long, but it's important to understand the theory and the practical aspect of dealing with circuits, all right, and how you can be comfortable with them doing the math, because as you can see, math is very important. And the take-home message from this video is that don't rely on the theoretical values of these resistors. Always measure them with a multimeter, always measure the battery level with a multimeter, and then do your calculations. Otherwise you will get different output, because if you can see here with our example, if we use 1k output will be different, right? So that's it for this video, guys. Thank you very much for watching. I will see you in another video.